Welcome to probability. This is chapter 6, and probability is an integral part of statistics. So we're going to say, when I talk about probability, I want you to think about what is the likelihood? What's the likelihood that something will happen? Okay, so let's keep it in that term. So we're going to start by talking about what's statistically significant. So let's say that I take a die and I roll it. And what I want to get, the outcome I want to get is, what's the probability that I roll a die and I get the number 3? Okay? Well, you could think about, in basic probability, that if we want to calculate the probability of an event, we're going to say the probability of the event is going to be equal to the number of ways you can get the event over the total number of ways. Total. So in our situation here, there's 6-sided. So to get a 3 is 1 out of 6. And that'd be about 0.17 or 17%. So the probability of getting a 3 is going to be about 0.17%. Now let's say I take that die and I could keep rolling it and rolling it and rolling it, and I roll it 500 times. I roll it 500 times. And when I add up how many 3s I get, I get 250 of the times out of the 500 I got a 3. And that's going to be 0.5. All right, so notice that there's a big difference between 0.17, which is what I would think I would get, and 0.05, 0.50. So we're going to define, this is like unusual. It's like a wow moment, right? And if we get a wow moment, we're going to call it statistically significant. We're going to say that it's statistically significant. Let's make this size a little smaller. So we'll say it's statistically significant. Okay? And we're going to even qualify what we mean by that. And we're going to say it could be one of two things. If it's if we had 1 out of 20, that's going to be 0.05. So if we expected a 0.17 and we get a 0.5, that's more than 1 out of 20. So that would be statistically significant at the 0.05 level. If we're looking at a 1 out of 100, and that's going to be a 0.01, and we're greater than that, then we are statistically significant at the 0.01. So we're going to define what we mean when we talk about our statistically significance. Okay? Just a couple more things about probability. Okay? This was section 6.1. In the rest of the chapter, they talk a little bit about different things with probability. So one thing that I think we need to be careful of, you can even say these are rules, okay? Rules of probability, perhaps. One of them says that probability of an event, let's call it P of A, has to live between 0 and 1. Okay, so if you have a probability of 1, that means it's happening. Okay, that means it's definitely happening. And if you have a probability of 0, that means it's not happening. Most of the probabilities of things happening, like rolling or getting a 3, is somewhere between 0 and 1. Okay. Rule number 2 is sometimes we want to know what's the probability of something not happening. So what's the probability of something not happening? Let me write it out instead of doing it like that. The probability of something not happening. Okay, so the probability of something not happening is going to be 1 minus the probability of it happening. So if the probability of rolling a 3 is 1 out of 6, the probability of not rolling a 3 is 5 out of 6. So these are rules that we can talk about. Let me expound a little bit more on rules. All right, and we're going to say that rule number 3, hopefully you can fit it on your page. I ran out of room. Rule number 3 is going to say the probability of A and B happening is equal to the probability of A times the probability of B if they're independent. So the probability of rolling a die and getting a 3 and flipping a coin and getting a head, the probability of rolling a die and getting a 3 is 1 out of 6. And the probability of getting a head is 1 out of 2. So the probability of getting both of those is going to be 1 out of 12. Okay, the probability of rolling a 3 and getting a head on a flip coin. Also, we sometimes talk about what's the probability of A or B. And that's going to be equal to the probability of A plus the probability of B if they're disjoint. If disjoint. This one was if independent. This is if disjoint. And what we're saying here is what's the probability of, let's say I've got a jar of marbles and I've got inside my jar, I've got red marbles and I've got blue marbles and I've got green marbles. Okay. So, and I want to talk about what's the probability that I pull out two marbles and I get a red or a blue. And that's saying that I replace them each time. So I pull out a marble. What's the probability that I get a red or a blue? So the probability that I get a red is going to be 3 out of, what do I got here? 2, 4, 6, 3 out of 6. Or the probability of blue is going to be 2 out of 6. And that's going to give me 5/6. Okay, so these are the different rules for probability. This is a good chapter to really dig into and practice and make sure that you understand things. Other things important in this chapter, if I could maybe just expand a little bit more on this page, if you've got room, or if you need to expand to another page on your thing, is there's something called the law of large numbers, and expected value. Okay, and the law of large numbers, the law of large numbers, is something we really use in statistics. So if in fact I'm rolling a die and I want to get a 3, I have theoretically I have a 1 out of 6 chance, but it'd be likely for me to not get a 3. Let's say I roll it 1,000 times, okay, and out of 1,000 times, I may get a 1, a 7, not a 7, a 5, a 4, a 2, then 3, then maybe I get 5 a bunch of times in a row, and then I keep rolling, and I get a 3, and I get a 6, and I keep doing this 1,000 times. If I, in fact, add up how many times I got a 3 out of 1,000, the law of large numbers said I would expect that I'm going to get about 17 out of, or 170 out of 1,000, right? Or if I did it 100 times, I'd expect to get it 17. And the more times that I roll with, the more likely I am to approach that theoretical. Okay, so that's what the law of large numbers says. The expected value kind of goes hands in hand in that if we are, it can give us the value that we think something is going to be. Let me say it in a better way by using an example. Let's say that I go out and I buy a lottery ticket, and the lottery ticket costs me $1. So the question might be, what's the probability that I'm going to win? Maybe the winning ticket is going to be 5 million, right? 5 million. Well, using expected value, we can actually calculate what the likelihood is, how much you expect to earn from spending that dollar. And it's a pretty simple, and you can do it on your calculator, but basically it's a weighted average. It's a weighted average that you use that says that over the long run, this is how much I expect to win when I buy a lottery ticket. So in short, that's what we've got in chapter 6. Good luck with it. Make sure that you read all the great homework problems that I have out there for you to look at, and make sure that you copy these concept maps down in 1 or 2 sheets and stick them in the drop box for me to grade. Thank you. Thanks for listening.